Good afternoon and welcome to the XMILE webinar. Last time we got a nice look at the introduction to XMILE, sort of where it came from and some of the capabilities from Karim Shashakli. And this week we're really going to look under the hood, as we put it in the subtitle, and it gives me great pleasure to introduce Glass-Husain, who will be talking about this. Now, Will has a long history in system dynamics. He's actually an undergraduate working on the system dynamics in education project with Jay Forrester. And he was one of the co-founders of Forio simulations. And one of the challenges they faced was to try to bring together models that have been created by different people in different languages in order to have them simulate online. And so XMILE is a great step forward for Will, and he's going to have a lot of enthusiasm today when he talks to you about its capabilities. So he's a chief architect and co-founder of Forio Business Simulations. And he's been working on a lot of the technical stuff. He's an active member of the XMILE technical committee and has been doing a lot of the work in helping create the spec. And it gives me, as I say, a great pleasure to introduce Will Glass-Husain. Will?
Thanks very much. It's a pleasure being here today, and welcome to everyone. As I said before, I'm in San Francisco, California, in Forio's offices here. And I'm delighted to be able to share with you a little bit about the technical details of XMILE. In the past, we've had webinars that have focused on a number of different applications and of system dynamics and of XMILE. And Karim Shashakli has talked about last session, presenting an introduction to XMILE and some of its goals. But today, my intention is to really dive into the meat and show some specific models, some specific equations, some specific XML formats, and give you a taste of what are the capabilities in this open standard. But first, a quick review. What is the XMILE standard? The XMILE standard is an open standard and a file format for system dynamics models. It's developed by the OASIS Technical Committee. The OASIS is a standard body sponsored by IBM. It was formed in June 2013, and the technical committee is composed of a number of people from different software vendors and also independent practitioners. But this format is not, this sort of the concepts behind this format is not new. I've been participating, and there's others who've really championed this concept, this idea of this open standard and file format for system dynamics models for many years, more than a decade. But it really started crystallizing in 2007 with a draft standard published by Karim Shashakli, and which later was presented at the System Dynamics Conference and became the starting point for the OASIS Technical Committee. Our schedule right now is to release a draft in July of 2014. We'll present it at the International System Dynamics Conference in Delft, and there'll be a roundtable discussion there. I'll talk a little more about some of the upcoming meetings and discussions at the end of the talk, with the final release and approval by the OASIS standard body planned for fall 2014. Let me talk a little bit about the technical goals of XMILE. What we're trying to do with XMILE is to capture the core subset of the common system dynamics simulation software functionality. And that's not always easy, but there's a lot of pieces that are common between them, and our intent is to capture them in this format. In addition, this includes not just the equation side, but also diagrams, the stock flow auxiliary diagrams, as an optional component. Also to include interactive components like charts and slide bars and radio buttons, again as an optional component. We want the XMILE format to be extensible in both the representation, that is, what kind of building blocks you have, and also the simulation behavior, so that there's a core format that's defined here, and then there's the ability for individual software programs or vendors to extend them. This should not be just a back-end format. We'd like this to be a concise, small file size. It should be human readable. It should be human editable. And when I show some examples later on, you'll be able to take a look at the file formats, and it'll be understandable. And then finally, note that we are focused only on system dynamics models. The intent is not, there's a wide variety of analytical tools and simulation approaches, but we feel that many of those are captured by other standards and other file formats. The goal with XMILE is really only a focus on system dynamics. Part of that, as a side note, is that the data types in the models that are computed are floating point numbers only. They're not integers, they're not booleans, they're not strings, just floating point numbers. So let me talk a little about why, before I jump into the actual file format, let me talk a little about why I'm really excited about this. I think that XMILE is going to promote innovation among the users and the software vendors. We've seen different examples of this in past webinars. But at a base level, you're going to be able to take an I think model. So for example, here's an I think model of corporate growth. This is a classic J. Forrester model, Salesforce, backlog, delivery delay, and these impacts on the corporate and the market growth. And someone's going to be able to build this model and share it with colleagues regardless of what software they have. So here's a model in I think, and I may have a parallel model in Vensim. I'll be able to save from one program and upload to the other. That's exciting. But as someone who is, my whole career has really been about not just, using these standard desktop modeling programs, but also taking these models and doing innovative things with them. And, for the last 14 years, it's been about taking models and building online web simulations. I'm really excited about the opportunity for complementary and other kinds of applications that use these models and can do innovative things. And so, for example, here's a little web simulation I've built. So this is internet. This is a Chrome, and I click this link here. And what I've done is I've imported those models into our Forio system, and I can actually do things like this is all an online page, and I can change the slide bars, rerun the model, and see what happens. And then you can do other kinds of analysis, like, for example, again, this is a classic model that looks at the impact of things like delivery delays, delivery delays on market growth. And so you can use third-party tools that will show and analyze your models or package them up and otherwise make them available to people. So the XMILE format's a key part of this. The way that we've done this at Forio in the past is we've laboriously gone through many of the common software packages and understood their language, but it's hard to keep up. It's hard, if the new versions come out, new things happen, this software's out of date. And so I'm very excited about the XMILE format for basically being able to take this model and put it in this program, and then being able to have other kinds of programs that can do things with those models. So enough of the introduction. Let's actually take a look at what the file format looks like. Here we go. Sorry. Let me talk a little more about how we're actually doing this in XMILE for the design goals. What we're doing is, as I said before, we're looking for the common features of system dynamics software. And so those common features we identified are the system dynamics constructs, stocks, flows, and auxiliaries, model diagrams, and explicitly being able to display variables or connectors between them. Computation, as I said, this is system dynamics, so a focus on things like Euler's method and Runge-Kutta 4. I'll talk a little more about this later. A wide variety of functions. One of the challenges is just to actually list out all the functions that supporting software should support. Inputs, text boxes, slide bars, outputs, graphs, tables. Not intended to be a comprehensive list, but these are the kinds of things that are common to all the software programs that we wanted to bring into XMILE. We also wanted to consider some of the differences and to figure out how to handle them. And if there's different software packages with differences in their capabilities, then either that should be an optional capability that is in the XMILE format that's supported by some but not by others, or it may be that it's just ignored. But we actually have quite an extensive list of optional capabilities. But first, let me just mention a couple of things that in the software may be present or absent. Things like you may have models that are text only. You may have pages that have input and output widgets, or other software programs may not support those input and output devices. Array capabilities, units. You may have specialized types of building blocks like your I think conveyors. You may even have differences in function definitions, and I have lots of examples. My favorite is int of 1.5. Int is a function that returns the integer part of a number, With int of 1.5, it's pretty obvious it returns 1. But what does int of negative 1.5 return? Does it return negative 1 because you just lop off the 0.5? Or do you return negative 2 because you're returning the lowest integer, the integer below that number? Turns out different system dynamic software actually, which have an int function, return different values. Some return negative 1 and some return negative 2. And then, of course, you might also have support for single model or multiple models, submodels, and also one or more diagrams. So these are all differences in the different system dynamic software we had to consider. Here's how we handle this in XMILE. It includes stocks, flows, auxiliaries. These are all standard components: graphical functions, groups, units, a list of built-in functions with specifications to handle those edge cases like negative 1.5. And then it has a series of optional components, model diagrams. It's a core part of the language, but not all implementing software is required to display the same model diagram. Interface objects, arrays, submodels, event triggers where you get to a certain value and it causes something to happen like the model to pause or stop, and macros. Macros are how you implement a new function. So you can actually define a macro that if there's a function that isn't supported in some packages, you can define it so that it can be automatically used in any XMILE supporting software that supports macros. And then, of course, things like conveyors. Now let's look at the actual format. Here's an actual XMILE model. I think of this kind of as the minimum model, in that this is just a simple interest savings bank balance model. Your savings, interest, the flow going in, interest rates. And what you see here is you see this model has several sections. It's got a header section that has meta information about the model, and although it's not shown here, it's also where you list what capabilities are required in the software in order to run the model. You've got your basic simulation specs: start, stop, DT. It mentions Euler's method. This is basic system dynamics, where it runs step by step. And then you have the model itself. And the primary building blocks are stocks, flows, and auxiliaries. And each has an equation. You can also specify units and documentation and dimensions if it's an array, but that's all within a section of variables within the model. So that's the basic format. Now you can see that although it has to be syntactically correct XML, it's actually a pretty simple format. It's easy to auto-generate. It's easy for software programs to read, and it's also easy to understand and to hand edit. And this is sort of more or less the simplest model you can do. Let's dive into this and look at some of the specifics in that format. That top level before, that last page of the model, had a header, sim specs, and the model. But there's actually a whole bunch of things you can do at the top level. You can do model units, you can do dimensions for arrays, there's behaviors, you can do styles. We're going to talk more about display and all the different characteristics you can do for the visual representation of models in our next webinar by Billy Schoenberg. So I won't talk too much about that today. You can have data loaded in. You can have models, and you can have one or more models. And then, of course, you can have macros. I'll talk more about. Today I'm going to talk primarily about models. I'm going to talk a little bit about macros. But briefly, the header section, which you saw before, I just had the bank balance in my sample model. I think this is really interesting. What the header does, there's all kinds of metadata you can use to describe your model, the name, the vendor, et cetera, et cetera. But the options is a key piece of it, because if your model uses some of those optional features, such as arrays, and the n means how many dimensions does it support. That should really be a number, so 1, 2, 3. What you're saying is that in order to run this model, here are the features you need to have in your software program. And, so if your model uses conveyors, you need to say uses conveyors, and then you need to have a conveyor available in the software in order to run that. The model I just showed didn't need any of these optional options, so it left that section out. Now, the main part we're going to focus on today is the model section. And in fact, there's two parts to the model section. There's the variables and the views. And I'm going to talk very little about the views. I'm really going to focus on the variables. But just to note, what we've done in the XMILE format is split apart the equations in the diagram. so they can be treated completely independently. On a given model has a list of variables, and the variables have name and equation and units and dimensions, and then the views have how they're displayed on the page, that width, height, x, y, the connectors, et cetera, et cetera. More on that next webinar. But by separating these out, it allows readability, so you can really understand how for example, the structure is laid out, how the equations are laid out, and it makes it simpler to do that hands reading and hand editing I talked about earlier. Let's continue to drill down. Back to our interest and savings model. So the main building blocks are stocks, flows, and auxiliaries. These are standard system dynamics components. A stock is an accumulation where things are added to every time step. So you can see here, for example, the equation is 1,000 for the savings, and the inflow is interest. And what that means is that every DT, every time step, goes time step by time step by time step, the interest is added to the savings. And you can have 0 or more inflows, 0 or more outflows. The inflows are added to the stock. The outflows are subtracted from the stock. It's very standard system dynamics structure. Flows are basically the variables that can be put into the inflows or outflows. So here I flow the equation, savings times interest rates. And then here is interest rates, and it's just a constant. So auxiliaries are other variables, and they can be equations or they can be constants. So those are the primary building blocks that make up a model. Let me show one that's slightly more complex. Let me go to the corporate growth model that I showed before, this model here. The XMILE format for this model, it's similar, just a little longer. I'm going to go to my editor here. There's lots of different XML editors. I'm using Notepad++, which colors things and automatically indents. But really, there's there's a wide variety of stuff. And here it's very similar. I've got a header which says the model and the vendor. I've got some style info, and then in the model, I've got a list of variables with stocks, inflows. It's got special characteristics like non-negative. It's got units and so forth, and that's it. And then we have the views below. So very straightforward format in that sense. Let me talk a little about some technical details. Identifier syntax. Identifiers are standard letters, underscore, $, digits, and Unicode. Unicode is sort of international characters. Identifiers can't begin with digit $, they can't begin or end with an underscore. What's great is that you can do arbitrary UTF-8 strings. UTF-8 is the Unicode, the international character set. You just use quotes. So if your variable name is A through Z in numbers, you don't need quotes. If you're going to have other kinds of, especially international characters of punctuation, just put them in quotes. And then finally, I want to note that it's not case sensitive. White space is treated the same, and underscore is the same as white space. That means that all these variables are the same. Interest rates, with an underscore, lowercase, uppercase, quoted, space, new line, /head is a new line, those are all the same. That means that you can have one representation displayed in a nice format like interest, new line, rate, and another with the underscore, which might be a little easier to work with and to parse. Other model conventions, we've reserved identifiers. You can do comments in line with curly braces. There's a doc element for documentation. As I mentioned before, it's floating points only. I talked a little bit earlier about the challenge of having function definitions, where the functions, the actual behavior may vary from program to program. So we specify in XMILE format a list of a number of different functions, and each function is actually accompanied by a specific technical definition. So I talked about ints before, and it takes one parameter, and it takes the next lowest integer. So as a note, negative factual numbers increase in magnitude. That means that int 1.5 is 1, int negative 1.5, negative 2. It's the next lowest integer. So we specify that behavior exactly. It doesn't mean that compatible software needs to have their int function match this one. But it means that when it imports the model in, if the definition is different, it needs to change the equation. So for example, if your software program it's implementing it is int and negative 1.5 goes to negative 1, then you have to put a an if statement in there to properly catch when it's negative and transform it to be a compatible function. The goal really is to have models that are built with XMILE simulate the same across all platforms. Briefly, the equation format, it's really what you'd expect. It's a standard infix style expression. Here, it uses the if, then, else control statement. If I have this equation, if time is greater than 2010, then return book revenue plus total revenue, else just do book revenue. When I put it in XML, I have to transform to XML by escaping the greater than sign. Standard function calls with parentheses for arguments. Function calls without arguments don't need the parens. You could do if, then, else sort of broken apart with 3 different words, or you could do a function if, then, else. You subscript arrays with parens. And then we have a list of standard operators with sort of a standard precedence. Everything from parentheses, powers, not, mod, and so forth. So this should be very familiar to you. Integration method is Euler's by default. We support sort of a set of typical RK4, RK2, and others. The last 3 are optional, RK2, RK45 gear. And the software program, if it uses one, should recommend that's not a standard, it should recommend a fallback. For example, RK2 is not always offered since it's not needed in one of these days of more powerful computers, so RK4 is defined as the fallback for RK2. A couple of other quick things. Model units, it specifies units, and units can be combined equations. This is optional. You actually don't need to specify the unit that's by itself, like dollars. But what's very useful is to be able to say dollars per person per year and then do an alias. And then in your variable, what you can do is you can refer to the units either with the full name or with the alias, dollars per year DPY, dollars per person per year DPY. Similarly, with arrays, you have a dimensions at the top of the model, where here I have an integer array, integer dimension product, which is 1, 2, 3. They all start with, it starts with 1. And a numerated dimension, location, Boston, Chicago, LA. And I can specify an auxiliary that has location by product, so it's a 2-dimensional array, and I have an equation. And this equation is applied to every element of the dimensions. Or I can apply it, I can do a list of every single subscript combination, Boston 1, Boston 2, Chicago 1, Chicago 2, LA 1, LA 2, and I can just say, I can basically give different equations for each different combination of subscripts. A couple more things. I mentioned earlier the macro capability. Our goal with XMILE is to support the common core capability, but then provide a means to extend it. And one of the ways that you could extend it is if a vendor implements a function that's not part of a common function, they can redefine it as a macro. And all implementing software that implements macros then should be able to read it. So for example, suppose that you have a log, you want to have a log function that's an arbitrary base. We don't actually have a log function in XMILE with an arbitrary base. We do have ln, natural log. So what you do is you define log as a macro, 2 parameters, x and base. You define an equation, ln x, ln base. It's got a little description, and now you can use that function log in your model. It's a great capability. What's nice is that vendors can actually make libraries of macros. There's an include capability where they can have files be automatically included, even downloaded or distributed that have their vendor-specific set of macros. You can take the macro capability a little farther as well. You might have macros that contain their own variables. So take, for example, a system dynamics style smooth function. Now, XMILE actually does have the smooth one function, but suppose it didn't. The smooth one is a very standard system dynamics construct where the smooth adjusts over a certain averaging time to the input. It's got internal variables. It's got an input that comes in and a smooth of input that goes out, but it's with the internal variables, you can have an internal state or internal sub parts of the equation. And it's just a nice little capability. It's a great way to extend the features available in XMILE. Wrapping up, there's a lot more in the standard I haven't had time to talk about. But wrapping up, I want to just highlight a couple of bullets of things that I think are very innovative. One of them is the ability to split simulations over multiple files. So you can have a master file, for example, that is a list of other files. and these are all versions, by the way, which is nice. This can allow modelers to split files for modularity. It can also, as I mentioned before, allow vendors to publish vendor-specific macro libraries. So they can have their specific functions be used by people running the models on other software programs because they define them as macros. You can also create new building blocks of macros. There's a whole other level to the macros where before it showed the building blocks of stocks, flows, and ops, you can actually have macros that are would define, for example, a conveyor or queue or some other kind of construct that you can, and then you have that XML tag for that construct. You can include data from CSV files or other sources, and you can specify events that are triggered when variables hit a particular threshold. For example, I built a simulation some years ago that someone does particularly poor in the simulation, it's a game, they get fired. And so you might have, when your profit drops below a certain amount, the game, the simulation stops. So there's a couple of events that are triggered, and there's also rules for this, and it's an optional feature. So I hope you've enjoyed this brief discussion of the details, sort of some of the meat of the XMILE format. The full spec is in draft form right now. It's 83 pages long. So there's not really been time in this brief webinar to cover the full exhaustive detail. But if you're interested, I hope that you follow up by looking more into it. We have a website for the technical committee. Not only is it discussions are public and drafts are public, you're more than welcome to join and attend some of our sessions. All the videos for the series are available at at the address below. And I also want to highlight a little bit about our webinar schedule. And this right now, we're on May 20th. We're in the middle of our XMILE overview webinar series. And we have, of course, we had on April 29th the introduction to XMILE. And today is the simulation capabilities. I do invite you to return on June 3rd when Billy Schoenberg digs into the XMILE format around the display and the interface. I think that's going to be sort of a great talk and a nice complement to the capabilities we talked about today. We'll follow up with a panel discussion with various people from practitioners in industry on June 24th, and then at the Delft conference, the International System Dynamics Conference in the Netherlands on July 21st to 23rd. It's going to be terrific. We're going to have a roundtable discussion. It's really trying to reach out to the system dynamics community. There'll be a ballot that offers you a chance to offer your feedback and your thoughts, and helps us to move forward with refining the standard and getting approval for it from OASIS in the fall. So having gone through all that, thank you everyone for your kind attention. I hope you enjoyed this session. I'm going to go ahead and turn it over to Kareem and Bob for questions.
Thank you. Thank you, Will, for the great presentation. I do want to point out the next one is being presented by both Billy and by Gary Baxter, both members of the committee, on June 3rd. Very brief description here. So we have our first question, which is, how do we know which stock a flow is associated with?
So you can tell which flow a stock is associated with from the from the building block definition. There was two parts to it. The stock had an equation, which was the initial value of that stock, and then it has a list, one or more inflow tags and one or more outflow tags. And the inflows, of course, are added in every step. The sort of the time, the inflow times the DT is added to the step. The outflows are subtracted, the outflow minus the DT for the step. Technically, I guess it's zero more. Technically, you could have no inflows and no outflows, but generally you have at least one of either one of both inflows or outflows, or one of either inflows or outflows.
Great. So in general, you search for the flow name in a stock definition to find out which stock it's associated with.
Right. So if you want to take an inflow and find out which, if you have a flow itself and you want to find out the stock, search for the tag inflow, the flow name, or the tag outflow, the flow name. The flows are actually listed in the stock.
Great, thanks, Will. Does XMILE interface to spreadsheets, for example, Excel, and also packages like Scilab?
So XMILE does not directly contain this specification on how to interact with Excel or Scilab, but it does have a data section in the model, and it does have some basic specification about CSV files. I think that's a really interesting point. That especially as this is an area for individual vendors or tool developers to create extensions. I should mention, by the way, that XMILE allows you to have vendor-specific extensions. It has its own what we call a namespace, and then IC or Vincent or Forio or some other tool, they can have their own additions to the file format. So if there's a software program that implements a Scilab connectivity, you can certainly take the data section of the XMILE format and put in something specific to that software program about the parameters for how to connect to Scilab.
Great, yeah, that's true. But the spec does have Excel spreadsheet import-export defined in the data section already. We're hoping to add things for ODBC, maybe not by the time the spec gets out, that may be later, and perhaps to URLs. But as Will said, anyone can add any extensions they want to. Next question, is there the notion of an XMILE conformance checker?
That's an excellent question, and I think the format is detailed enough, and of course the whole point is for compatibility between multiple applications and multiple tools. It's really useful. We are publishing an XSD, an XML schema, with the spec, and you can use that XSD to, there's many automated tools that will that allow you to use an XSD to check the conformance of the XML. That, of course, will check to make sure the tags, the elements are correct, the attributes, as well as the data types. We've talked about in the technical committee actually releasing a more detailed reference check, sort of a syntax checker that would also do things like check equations, format and so forth. It's not clear if that's going to be in the draft release, but I think the XSD is a good step towards it. Of course, one great thing, because it's an open standard, particularly once this is released, it's a great opportunity for someone to build an add-on to it. Take the XSD and build something that's even more sophisticated for checking performance. Hopefully, releasing it as open source, allowing other people to benefit.
Great, thanks, Will. Somebody's asking if a how-to book will be written. How to XMILE.
A how-to book will be written if someone sits down and writes it. The great thing, again, is this is not one person, one vendor. It's an open standard, and I invite people to do that.
Thanks, Will. And of course, the place to start if you want to do that is with the spec. Are there any open source SD tools planning to use the XMILE standard? And I'm not sure Will knows the answer to that. I know I don't.
I don't know of any, but I'm really excited about the opportunity for open source. I have a lot of experience personally in the open source community, and I know that myself, just as a software geek, I built many different versions of system dynamics and other kinds of model parsers and computation engines. I think it'd be great if, and what happens a lot of times is you build these tools. Like years ago, I built one in HyperCard, and I built one in C in Visual Basic, and I see people who have done things that are web-based or on GitHub. The problem is they're all isolated from the rest of the market. There's no way, say, if you start with an open source tool, and then you want to do something more sophisticated to switch to an iThink or Vincent or PowerSim. And I think that hurts the adoption of them, and it also makes it harder for people to get into the field. So I think it's really exciting that this common file format is going to actually open up the field to tools of many different degrees of sophistication and markup, some proprietary, some open source, and then you can migrate among them. I think it's good for everybody. I'm not aware of any yet, but it wouldn't surprise me if we see some next year.
Thanks, Will. The following question, of course, is what major software packages will end up supporting XMILE for both input and for output? I do know the answer for most of that, but I'll let Will start because he can talk about Forio.
Sure. Well, I'll mention Forio, and then I'll turn back to Kareem for others. Obviously we're interested. We let people, our company lets people build models in a variety of tools and upload them onto our site and build web-based simulations. And so, bringing in models is just a large part of our interest, and XMILE is going to make it easier. So, we do intend to import system dynamics XMILE models. Kareem, maybe you can speak for others.
What about exporting models? They were asking about input and output.
It's possible we'd export. So Forio is not really a modeling software. Forio is really about consuming models and building applications out of them. So although we do have our own text-based system dynamics language, it's sort of vaguely Dynamo-like. So we haven't made a call on whether we're going to export from that or not. Since many people are more focused on bringing stuff in than out, I don't know. On the other hand, if we go to all the trouble of importing them, might as well export. So it's definitely a possibility.
Great, thanks, Will. Yeah, that's a critical point about the Forio solution. It is mostly for consumption of models, not for building models. So it's a little different than some of the other tools. IC Systems is committed to putting it in and supporting it in all of their products. Ventana Systems has gone on the record as saying they're going to support it in their products. PowerSim has not said yet. They're waiting for the spec to be approved. AnyLogic has said that they will at least import models. They have not necessarily said they will export models. Those are the only people I know about for sure. The next question is, will there be a sort of XMILE editor?
Well, the great thing about XMILE is that it's XML, and there's lots of XML editors, especially when you combine with the XSD, the XML schema, which allows you to specify elements and data types. There's a lot of intelligent XML editors that make it easy to create these things and make sure they're valid formats. So I don't know of any plans to for anyone to make something with XMILE, but again, it wouldn't surprise me once this is an open standard.
Yeah, and I'll just add to that you can edit the XML directly. That's one of the great things about XML. There are lots of open source tools out there that allow you to manipulate and manage the XML and generate reports from it. But XMILE is also a language for system dynamics models. So, of course, I think in Stella you can edit XMILE models directly, and anything else that supports them will allow you to as well. The next question is, how could XMILE be incorporated into high-performance computing, for example, for sensitivity runs?
It's interesting you mentioned that because this is in the category of innovation of third-party tools that consume models and do things with them. And I'm not an expert in this by any means, but this is a great application, I think. I know there was work years ago at the I'm going to speak very limited knowledge. It was work years ago at the University of Illinois where they took, I believe, Stella models and ran them through parallel processing. Made it sort of these enormous spatial models. And I think it's a nice opportunity for people to build models using the desktop software. You've got that very nice visual box, those bubbles and arrows we call them, the boxes and arrows, so you can see the cause and effect. And then you want to take that to something where you blow it up, by millions and millions of cells, and so you can simulate it in a very high volume way. You'll need a specialized program to do that, but I think this is a nice opportunity to migrate the model into that system.
Thank you, Will. The next question is, does Stella convert an XMILE XML form of equations into their equation format? And I'll probably answer that. The native format that Stella and I think are using now is XMILE. So when we save a file, an ITMX or an STMX, it is an XMILE format already. So that's the native format at this point. Will XMILE go beyond SD methodologies, system dynamics methodologies?
I would say that at the moment there are no plans for it to do that. Of course, you don't actually have to have stocks. If you wanted to have a modeling, a model that is more of an input-output model, that is just a set of equations that would work fine. There are no plans to add other kinds of simulation capabilities like discrete modeling or other kinds of data types or agent-based or anything like that. That's really not in the purview of our technical committee.
Yeah, that's exactly right. Our technical committee for the version 1.0 is limited to system dynamics. However, for 2.0, we can look at, we can talk about other methodologies, for example, discrete event simulation. And we have talked with the BPSim people to see if there's maybe a way for us to merge our two solutions to have one solution that has both discrete event and system dynamics in one place. Who knows where that will go? Again, that's going to be more of a 2.0 version of the spec after the 1.0 gets passed. Our committee is very limited in how much we can add beyond what was in the draft specification. How can one get involved? Good question. Will, do you want to take that?
Well, I think the the best opportunity is when our next draft gets released. So the way that the OASIS process works is the committee develops and releases a series of drafts. We released one back in, Kareem, you'll probably remember the date. I think it was December, and then that's available for public review. And then our next draft will be released a little before the System Dynamics Conference in Delft. And if you're a member of the System Dynamics community and at the conference, that's a great opportunity because we're going to have discussions and a ballot and so forth. If you're not, the draft will be available for download, and we'd love to get your comments. In addition, if you have more availability and interest, you can also attend our committee meetings. There's some requirements to go through in order to join the OASIS organization and then attend the meeting. But we are looking for new members, particularly those, or rather both those from software field, but also those from practitioners and from industry.
Thanks, Will. Here's a really important point that a lot of people, I'm sure, are wondering about. Is it a requirement that the same XMILE model produce exactly the same results when run on different systems, in other words, vendor platforms? I have in mind floating point differences, random number generator implementations, etc.
Kareem, do you have any answer for that?
I do, in fact. So we're going to have a set of benchmark models that we expect the results to be the same, but when you get into random number generation, the spec does not say you have to use this generator and it works this way and that way. It says you need to create, for example, a uniform distribution. So you may not get exactly the same numeric results if you have random number generators in there. You won't get exactly the same number of the exact same results if one system uses single point floating precision and another one uses double point, but they should be close. So there will be subtle differences out in the decimal places. There will be subtle differences in the order of random numbers generated for random number generators. Another question is, are CLD supported directly in the spec?
Well, we're going to cover this more in next week's talk on the display of the interface. But Kareem, can you comment on that? Do we support items linked together in CLDs without the equations?
Yes, it's quite possible to do that. So while they'll be talking about it a little next week, I don't know if they'll focus on CLDs, but you can certainly create and save CLD representations in XMILE. Will XMILE have an API, an application programming interface?
Well, XMILE is not an application. It's not a software that has an API, and it doesn't define an API per se as part of the spec. However, you can, of course, implement a parser for XMILE that would read in files, and or a software program that would read in XML files and provide the API. But that's not under the direct sort of purview of the technical committee. That's more responsibility of implementers of the spec.
Terrific, thank you. So I think that's the limit of the questions we have for today. I think we're out of time. If you want to, I think Bob's going to close us up. Thank you for joining us. I just wanted to again tell you that we're going to meet again on June 3rd, and Bob will pick that up.
Great. Thank you so much, Will, for that talk, and thank you all for asking some really great questions. I hope that you've learned a lot and enjoyed this. Please do join us again on for the next webinar, where we'll be talking about the interface layer and what things look like from the user's perspective. So that's June 3rd, again at noon Eastern Time, and that'll be by Billy Schoenberg and Gary Baxter. And we'll follow that up with a roundtable discussion with a panel of people from the System Dynamics community, which should be very good. And of course, as Will mentioned, then we'll be at the System Dynamics conference, and hope that many of you will be able to join us there in person. Thank you so much, and have a great day.